Day three. Today is mostly an exercise day. We're gonna get some practice doing recursion. I have a quote here from Alan Perlis, the famous and important thinker in computer science. Yeah, I have a link here to his quotes page. Lovely set of quotes. Every time I go to these, I understand one of them. Like I look at one and be like, oh, I never understood that one, but something recently happened to me where I see why this is true. Look at them and you'll see that many of them seem banal. They're also like a little dated. I think many. Not too bad, I don't. But they're actually really often deeply, deeply insightful about what's important about programming and programming. So the one I have here is recursion is the root of computation. Greatest description we're going to work on today. We're going to work. I want to start with a little quiz. So this quiz is not for a grade or anything. It's an understanding check. Uh, I like to do these at the beginning of a day so that everybody knows kind of where they stand. If you get the quiz straight away, you know exactly what we're talking about. Golden. You're ready to move on. If you kind of get it and then I show you the answers and you're like, oh, okay, yeah, that makes sense. Like, okay, cool, but maybe check up on the parts that weren't obvious to you. Right? These are things that we hope are sort of like quick or easy for you. Often, not always. In this case, I think it's something I hope is. If you get there and I give you the quiz and you're like, I have no idea. Okay, you need to talk to us, right? You're missing something. You're not ready to move on. So let's get you unstuck and figure out what it is. No shame in that. We just got to work it out. Okay, so let's get on with it. Let's check our understanding. Let's see where we are. Here's the quiz. How would I have the old version? How would you write a function double that takes a natural number and doubles it? Pause the video, think about it. There are a bunch of different ways to do this. You could write non-recursive definition. So if you have one, can you come up with the other? Pause the video again. Okay, let me show you a couple samples. So here's one. So I'm going to write all the types here. Typically, when we do these quizzes, we're going to ask you, "Hey, maximal types," just to sort of like check yourself. I mean, obviously, we're not going to. But so here's one way to double a number: n plus n. Control X1 says give me one window. Control X2 says give me two windows. Uh, and then Control XB lets me switch buffers. And now I have my nice response window down. Okay. Uh, Definition double prime. Here's another way to do it. Or you could do n times 2. That's good too. Here's another one. Right? All these will behave exactly the same. Uh, One better than another. Well, what does better mean? Right? The first two are concise, really nice. Um, the second one offers this nice intuition that says, "Hey, to double a number, turn every successor into two successors." Oh, that's clever. That's nice. You might think about efficiency. It's already been brought up. Not the focus of the course, but I'm happy to talk. These are all more or less equally efficient. Because how does plus work? Well, plus is recursive on its first argument, so it's going to have to take every successor here and put a copy of that on these. This 2 times n, well, multiplication is an iterated plus, so this is going to be n plus 0. Okay, that's actually going to be worse, right? Because if this turns into n plus, uh, it's left to, or if it's left or right, say it's right. Right here, this bit will involve n steps of recursive calls, and this we'll call another. So this, which seems like better, right? We're only mentioning n once, right? We're using multiplication. It's simple. This in Cox's model of evaluation is much more expensive. On your computer, they're about the same. All right. This version, okay, this is also just a straightforward recursion, right? So this is about the same as the original double, but different from double. You might have come up with something like more wackadoodle. Uh, like you could do this. Let's like, yeah, throw in an extra one and then get rid of it. I don't know why anyone would ever want to do that. Any sense? It's harmless, right? You're not going to ever hit the truncating behavior of minus because we've got enough ends there to account for minus n. Just like, why would you choose? Okay, in the rest of the file, I'm going to talk a bit more about function definitions and recursive functions. You're going to define a couple more, and at the end, we've got a series of exercises, sort of ramping up in difficulty, having you write some interesting programs, thinking about binary and then trinary numbers. Okay, should be fun. Talk to y'all soon.